Okay. Alrighty, so we're solving inequalities here, and you've solved inequalities in the past, but these get a lot more in depth than what we did back in Algebra 1 and Algebra 2, okay? And I will tell you this, a little bit of a clue. When you're solving inequalities, you solve them just like equations, except for there was one little rule that we taught you back then, and a lot of students forget it. A lot of students forget this rule, okay? Now, when we look at these, we're not solving inequalities at first. They simply ask us on number 1, express the inequality as an interval, and it says sketch the graph, okay? Well, sketching the graph, and just so you guys understand, we'll get very, very basic here. Inequalities, I mean, the definition of inequality means not equal to, okay? So it's not an equation, okay? And there's always two ways you can express any inequality. Like, for example, our ages are not equal, okay? My age and Schofield's age are not the same, okay? There's two ways we can explain that. We said K.O.'s age is bigger than Schofield's age, or you could have said Schofield's age is smaller than my age, okay? There's always two ways you can say it. So I always like to put the x first, okay? You don't have to. I think it's just easier if you put the x first, okay? So to graph this thing, if you remember the way you do it, okay, you put, first off, x has to be by itself, and it is, okay? Most of these questions on this worksheet, x is not by itself. And then, do you guys remember it would be an open dot or a closed dot at -2? You guys remember that from Algebra 1 and Algebra 2? It's going to be an open dot. And the reason is, it has to be is -2 less than -2? No, it's equal to it, okay? So you don't include -2. That's everything less than -2, so everything to the left. If you have an equal sign under it, you shade it in, okay? You close up the dot. That says everything less than -2 or including -2, okay? Nothing new there. I mean, it's been a while since we did these, so it's just review, but it's a review from a few years ago. They also ask you to do something in interval notation. Interval notation, okay? Now, just watch for a second. I'm going to give you a couple of examples, then we're going to give this answer in interval notation, okay? If I gave you this right here, if I give you this graph, now let's make it open dots. In everyday language, we're talking about numbers between 4 and 7, including 4 and 7 or not including 4 and 7? Not including. They're open dots, okay? So the way we would have written it back in Algebra and Algebra 2 is you'd say 4 is less than x is less than 7, okay? But we want it in interval notation, okay? And you got to be careful here because if I'm going to put the answer up on the board here, and if somebody just walked in, they'd look at my answer and say, oh, I know what that is. It's different than what you've learned, okay? And what I mean is this. Interval notation would be 4, 7 with parentheses around it, okay? Now, you learned, I mean, if I simply, what I was talking about is if I put this up on the board, okay, and somebody just walked in, there you go, oh, yeah, I know what that is, 4, 7, that's the 0.47, okay? Yeah, it is the 0.47, okay? But when we're talking about inequalities, this is called the solution in interval notation, okay? Now, what if I had filled these dots in? Then it would be 4, 7, but you put brackets around them, okay? Brackets mean you include the endpoints. Parentheses means you don't include the endpoints, okay? So if I give you something like this, and if I gave you this right here, how you'd write that answer in interval notation? I mean, in everyday language, it's numbers between -8 and 7, including or not including the endpoints? Including one of them, including -8, but not including 7. So how you'd write this in interval notation is -8, 7. You're including -8, so you put a bracket, and you're not including 7, so you put a parenthesis, okay? So parentheses means you don't include it. Brackets mean you do include it, okay? Now, what if I have something like this, okay? And also, when you're doing it, you always have to have the lower number than the higher number, okay? You can't have it like this. That's incorrect, okay? If you want to say between 1 and 3, including 1, but not including 3, I should have put 1 first, then 3, okay? You need to have the lower one, then the higher one, okay? Lower than higher, okay? That's just the right way to do it, okay? All right, so let's look back at this question. This one's a little bit tricky because what's the smaller number here? Well, that arrow means it goes that way forever, okay? Goes forever, okay? So you can't really name that number.
Negative.
What's that? I heard somebody say it.
Negative infinity.
How come negative infinity?
Because it's going down that way.
To the left, yep. because it's going to the negative direction. Now, if I would have shaded this way, it would have been positive infinity, okay? So I put negative infinity, comma, -2. Do I include -2? No. And I haven't answered this one yet. I'm curious what your guys' responses are, though. Do you think I put a bracket around negative infinity or a parenthesis? Do we include it or not include it? Any guesses? That's okay, I haven't told you yet. What do you think? Do you include it or don't? We don't. You know why? You never get there. You can't include something that you never get to, okay? I mean, you can go that way for 80,000 miles, okay? It doesn't matter, you keep on going farther, it goes forever. You can't include something that you never get to, okay? So any infinity symbols always have parentheses. They don't have brackets. You never ever get to it, okay? So, all right, let's look at the next one. So that was one of the new things in this section is interval notation, okay? Let's look at number 3. We have -3 is okay, so let's go ahead and graph this. Okay, they want the graph and they want it to be an interval notation. So our graph, make sure you put them in the right spots also. We should have -5 to the left of -3 because -5 is to the left of -3 on the number line. And then we're going to have a closed dot at -3 and an open dot at -5, and we shade in between them. Because we're talking everything between -3 and -5, including -3, but not -5. And then we write this in interval notation. Again, interval notation, you go from small number to big number. So -5, comma, -3, parenthesis around -5, bracket around -3. One more thing, and you don't need to know this, I'm not going to test you on this. If I give you something like this is something called an open interval because it has an open dot. If you have brackets, it's something called a closed interval. What do you think that is, open or closed? Well, you could say it's either half open or half closed. It's the same thing. I say half open, you say half closed, we're talking about the same thing. Part of it's closed, part of it's open. So, tomato, tomato. Okay, number 5. Okay, now we're working kind of backwards. They give us this, and they ask us to write it as an inequality, okay? So, they didn't ask us to graph it. I'm going to also, though. I'm going to graph it and then come up with the inequality. So I put the -5 here and the 8 here. -5 is open, 8 is closed, and shade in between them. So what we're saying is numbers between -5 and 8, including 8, but not -5. Okay? So, and I know that in Algebra 2 we talk about it, but not very much, and almost every student, you guys included, struggle with this because we just don't do enough practice at it. There just isn't that many problems that you did in Algebra or Algebra 2 when you wrote inequalities. When you're writing inequalities like this, put the smaller number, leave a space, put an X, leave a space, put the other number. And you always put less than signs. Less than signs. Always. If you go small to big, put less than signs. Okay? And they always face the same direction. You can't have a less than and a greater than. That wouldn't even make sense, okay? And the reason why you do less than signs, if I did that, think about it. If I told you this, okay, forget about this question for a second. I'm going to use some people that I honestly don't even really know, okay? Well, some of them I do, but I don't know their ages, okay? Meerkat, your grandpa, his age is older than me. And I am older than, you got younger brothers, don't you, Jonathan? Okay, then you're one of your younger brothers, okay? So, Meerkat's grandpa's older than Ko, and Ko's older than one of your brothers. Wouldn't it stand to reason that his grandpa's got to be older than one of your brothers? Has to be, okay? If we did this, if -5 is older than X, and X is older than 8, -5's got to be what? Bigger than 8. Anybody got a problem with that? -5 is not bigger than 8, okay? So it's got to be less than signs, okay? But under 8, we're going to put a equal sign because it's filled in, okay? We don't put one around -5. Okay, these are kind of the boring ones. Let's actually get into some of the more interesting ones here in a few minutes. All right, so look at number 7. Okay, hoping that Oh, shoot. There's one little rule, and I'm not going to give it to you yet, that you have to remember when solving inequalities. Okay, it's just like solving equations, except for one little rule that you got to remember that lots and lots and lots of students forget. Okay, so I'm going to subtract 2x to each side. Okay, these cancel. We have 5 is less than x minus 7, and then we add 7. Okay. Now, nothing wrong with that answer. Nothing's wrong with that. I always like to have x first. Just it's easier for me. Okay. So instead of saying 12 is less than x, I could put x here and 12 here. Just switch everything. Put the left side on the right side on the left side, but then also turn it around. Okay? Now they want it in interval form. Okay, so they sketch it, solve it, express it. Okay, I'm going to sketch the graph. They don't tell you to, but I just think it's easier. At 12, we would have an open dot, and it's bigger, so we shade to the right. Okay? So in interval notation, I'm going to tell you right now, if you're sitting there going, oh, I don't like interval notation, well, you got about a week and a half to learn it, because on your test, it's going to say give the answer in interval notation, okay? This is one of the new things I want you to know. So interval notation, we put 12, comma, it goes forever, but it's to the right forever, so it's positive infinity. We don't include 12. Do we include infinity? We never include infinity. What's that? Parenthesis. You never include infinity because you can't include something that you don't get to.
Mr. King,
Yes, sir.
do you have to have x before the 12? Is that why you did that?
Like, did I switch it? Here's what I do, and I teach this in Algebra 1 this, okay? I really don't care. I don't care. What I tell my algebra kids is this. You remember those teachers sometimes call them alligator mouths? Okay, we try to get away from that. We want you to understand that. Think of it also this way, though. Think of it as an arrow. If you always put x on the left, this arrow points the way you shade. I do that so kids can remember that. Now, if you want to do it the other way around, that's fine. But then you need to remember if x is on this side, it points the way that you don't shade. So I don't care. To me, it's easier if I put x first. But you don't have to do that. Okay. All right. Number 9. Never did one like this in Algebra 2. Number 5. Any idea how we're going to start this thing? You guys like fractions?
Love
Love them? I don't like them. What'd you say? I don't like fractions, okay? I want to get rid of my denominators.
Multiply the fraction
By what?
by -5.
Not -5. I would just do 5. Now, we've said for years, whatever you do to one side, you do to the other. We're not going to times both sides by 5. We're going to times, how many sides are there here? 3 sides. There's the left side, the right side, and the middle side. We're going to times all the sides by 5, okay? So times everything by 5. So 15. These are going to cancel. We're left with 2x minus 3. 5 times 7 is 35. Now there's no fractions. Then what? Add 3 where? To both sides? Not both sides. All sides. Add 3, add 3, add 3. 18 is less than or equal to 2x is less than 38. And then the last thing we have to do is divide by 2. We do that. 18 divided by 2 is 9x. And I'm not going to graph this one, okay? I mean, if I did, we'd have dots at 9 and 19 and shade in between them. So in interval notation, we'd put 9 comma 19. We'd have a bracket around 9 and a parenthesis around 19. Between 9 and 19, including 9 but not 19. I'm just curious, and it's okay because almost everybody forgets this rule, okay? Do you guys remember the one little thing you have to remember that inequalities, like if I give you this right here, if I gave you 2x minus 1 equals 7, 2x minus 1 is bigger than 7. Which of those is harder to solve, would you say? Or are they the same, would you basically say? They're the same, okay? You solve them both the same way, okay? So, solving inequalities isn't any harder than solving equations, except for one thing. Does anybody think they remember what that rule is?
Is someone division?
It definitely has something to do with division.
Switch the lesser than or greater than sign for some reason.
Exactly. He's close. He's really close. He's missing one thing. He said you have to flip that inequality symbol around sometimes. He said something about dividing. Not just, I mean, we divided, well, did we divide here yet? Yeah, we divided by 2. We didn't flip them. And this is right. This is right. Nobody remembers? When you divide by a negative. Whenever you or multiply. When you multiply or divide by a negative, you got to flip them around. Here we times by positive 5. If this was a negative 5 here, if this was a negative 5, we would have times by negative 5, and then we'd have to flip both of them, okay? So that's the only thing that's new. Whenever you multiply or divide each side by a negative, you got to flip around. And that's huge for the problem we're about ready to do, okay? So, and that's what you need to remember. When you multiply or divide by a negative, you have to flip the inequality symbol around. Okay. So, again, think about what I just told you guys, okay? Now, we just said a few minutes ago we don't like fractions. Okay? I don't like fractions either. Okay? So back here we times everything by 5. We times everything by 5, okay? So, yes or no? I can times each side by 3x plus 2. And when we times by 5, because that was the denominator, can I multiply each side by 3x plus 2? No, you don't sound real confident. You're right, no, you cannot. Why? Why can't we times by 3x plus 2? We can times everything each side by 5. Why can't I times by 3x plus 2? Here's why. Okay? When we times by, why didn't we flip these around? We timesed, not by a negative. So, okay, let's times by 3x plus 2. Am I going to flip this around? Yes or no? What do you think? Are we timesing by a negative? Why? What are we timesing by? By 3x plus 2. Is 3x plus 2 negative? Careful. Is 3x plus 2 negative? Looking for one word. It depends. Really, it depends. If x is 4, what's 3 times 4 plus 2? 10. Plus 2. 12, 14. Okay? Positive 14. What if x is negative 10? What's 3 times negative 10 plus 2? That's all I need to hear, negative. So do you flip it or don't you flip it? Somebody say it. I don't know. We don't know. It depends. Okay? So here's what this whole work, the main thing, most of this is just review type stuff for the most part. Okay? I mean, there's a few little things here. You cannot multiply each side of an inequality by anything that has an x in it. Okay? So if I give you this right here, 9 over x is bigger than 2. Could I times each side by x? No, you can't. Because x could be positive or negative. So you might flip it, you might not flip it. So how the heck do we do these? Here's how. Okay? First off, you have to have 0 on one side. Looks pretty good. We got 0 on one side, okay? Then what you do is you look for critical values. Okay? Critical values. In this case, there's only one critical value. Okay? And I tell you what, one more thing. Just watch for a second here. There's another reason why you couldn't times by 3x plus 2. If we did that, these cancel. So we'll have a 4. 3x plus 2 times 0 is 0. You know what my response to that is? Duh. I mean, seriously, 4 is bigger than 0? No kidding, okay? 4 is bigger than 0. We know that, okay? And not only that, did we get x by itself? No, x is gone, okay? This is similar to what Jonathan said a week or so ago. He said, can we multiply each side by 0? That'd be nice. This class would be so easy if you could multiply each side by 0. Every problem I ever give you, times each side by 0, you're done. You say 0, 0, 0 equals 0, 0 equals 0. But that's not really telling you anything. It's kind of like saying, when somebody asks you who you are, you say, I'm me, okay? Is that a true statement, I'm me? Yeah, but it's not really telling you anything, okay? So we need critical values. In this case, there's only one critical value, okay? And the critical value in this case is negative 2/3. Negative 2/3. Any idea how I came up with that critical value of being negative 2/3?
Oh, did you do that thing we've been doing lately where you like flip the numbers and put the second number on top and first number on bottom? We've been doing that a lot.
I can see what you do, I don't know how to explain it though.
What's so special about negative 2/3? I mean, it's a critical value because, well, tell you what, if I give you this, let's do an easier one. Critical value here
Negative three.
is positive 3.
Oh, yeah, positive.
Why?
Yeah, because you're taking the x minus.
What happens when I plug in 3? You get what where? Hmm?
You get 0.
Where?
On bottom.
Bottom. You're making it too hard. On bottom. Okay. Now, if I give you this, this has two critical values. 7 and negative 2. That would should clear things up. What are critical values? And the numbers that do what? Make
0.
0 where? On bottom. Keep looking. 7's a critical value,
And top.
as well as top. That's all critical value is what makes 0 on top or bottom. Okay, that's all the critical value is. Whatever makes 0 on top. So negative 2/3. And how I got that? I took the opposite of this over that. Okay, negative 2/3. Now, how do I get 0 on top?
You don't
Hmm?
need, you don't need to.
Well, how do you get 0 on top? Sort of a trick question. You can't make 0 on top. What's on top? 4. When? Always. It's always 4. You can't. That's not going to change. Okay, because there's no x up there. Okay, there's only one critical value. So here's what we do: we draw a number line. Negative 2/3. Okay, negative 2/3. We did problems similar to this back in Algebra 2. It was a while ago. We didn't do a lot of it. Okay, we pick a number to the right of negative 2/3. Okay, all I really care about is the sign. I don't really care about the number. I want to know if it's positive or if it's negative, okay? So if I pick a number to the right of negative 2/3, I'm going to plug in 100. I'm going to plug in 100. You know what 3 times 100 plus 2 is? You might say it's 302. You're not wrong. All I really care about is that it's positive, okay? 3 times a positive 100 plus 2 is positive, a positive number. 4 over a positive number is what kind of a number? A positive. Everything, now I could have plugged in 0 if I wanted to. 3 times 0 plus 2 is a positive number. 3 times 0 is 0, plus 2 is 2. 4 over a positive 2 is a positive number. Anything to the right of negative 2/3 is positive. How about a number to the left of negative 2/3? I'm going to plug in negative 100. 3 times negative 100 plus 2 is a negative number, some sort of negative number, okay? 4 over a negative number is a negative. Do you guys vaguely remember doing this last year in Algebra 2? Or does that look totally, we didn't spend a lot of time. Now I will tell you this, if you remember this from Algebra 2, if you remember it, I told you in Algebra 2 that these things will always flip-flop. I also said that if you take FST, that won't necessarily be the case. And I told you back then, and it was over a year ago, okay, it was over a year ago, and I'd said just they'll flip-flop. And I didn't explain why. And I said when you get to Algebra 2, when you get to FST, I will explain why, okay? I'll be right up front. You don't have to know, okay? But I do think it's important that you, at least to be exposed to it, okay? I'll tell you why they don't always flip-flop. Sometimes they do, sometimes they don't, okay? Now, what do we care about? Where it's positive or where it's negative? And be careful. Some students say, well, positive, because we don't like negatives, okay? You got to read what it says. What do you think? Do we want to know where it's positive or where it's negative? Any guesses?
Positive.
Why? You got to look at the board. It's on the board. It's definitely positive. Because it says this. Okay? What do we call numbers bigger than 0? Positive numbers. What if it said this right here? Now what do we want? Negative numbers. Okay? This is tricky. This is really, really tricky. I'll give you a clue. Okay, I'm going to give you a clue before I ask it. Why is this a critical value? Jonathan answered it a few minutes ago. Why is negative 2/3 a critical value? It does what? It makes what?
0.
Keep talking. 0 on bottom. 0 on bottom. Okay, so we want this. Think back to what Meerkat just said. It makes 0 on bottom. So we're talking about everything to the right of negative 2/3. So it's gonna be negative 2/3, comma, to the right forever, so infinity. Do I include infinity? No, we never include infinity. This is where it's tricky. Do I include negative 2/3?
Yes,
Why do you say that?
because it makes 0.
Well,
And you're greater than or equal to.
it has an equal sign there, so your gut instinct ought to be, yeah, we include it. You don't though. Why? Why don't we get to include negative 2/3? You already answered it once, just 30 seconds ago. It has an equal sign, it looks like we're supposed to include it. We can't include it though.
Because then you'd be divided by 0.
You get 0 on bottom, and you're not allowed to do that, okay? So you don't get to include it, because you get 0 on bottom, okay? And you're not allowed to divide by 0. That's not a number, okay? Dividing by 0 is not a number. Now, if you're sitting there going, I didn't get that, it's okay. Here's the good news, bad news. The rest of this worksheet's just like this, okay? But they get a little bit tougher. Let's do a few more just to kind of get it sinking a little bit. We're not going to rush through this worksheet. This is a tougher worksheet. Okay. 13. All right, so we have negative 2 over. I'm going to write this in the right order, okay? I'm not going to write 4 minus 3x. What should I write first?
3x. plus
Careful, not 3x.
4. Negative 3x.
Negative 3x plus 4. Okay. We have 0 on one side. Is that a good thing or a bad thing? Good thing. If it doesn't have 0 on one side, first step is make it have 0 on one side. Okay? All right. Critical value. There's only one of them. Okay? And if you're stuck on this, watch carefully because it's real simple to find the critical values. You take the opposite of this number, divide by this number. So negative 4 over negative 3, which is 4/3. How do you get a 0 on top? You can't, because there's no x on top. Negative 2, I don't care what you plug in, you're always going to have negative 2 on top. Okay, you'll always have negative 2 on top. Okay? So, let's draw our number line. 4/3. Pick a number to the right of 4/3. I'm going to pick 100. Okay? If I plug in 100, I'll tell you what, I'm going to do this. I don't want an actual number. I want to hear one of two words. Positive or negative. That's all I care about, okay? I'm going to plug in 83,917.28. Okay? Positive 83,000, whatever I just said, 924.78. What's negative 3 times that humongous positive number?
Negative.
Negative plus a 4.
Negative.
What's a negative over a negative? Okay. Now I'm going to plug in negative 38,925.64. A huge negative number. What's a huge negative number times negative 3?
Positive.
Positive. What's a positive huge number? What's a positive huge number plus 4?
Positive.
Still positive. What's a negative over a positive?
Negative.
What do we want? Where it's positive or where it's negative?
Positive.
Why?
Greater than 0.
Numbers bigger than 0 are called positives. So we're talking about this area. 4/3, comma, infinity. We never include infinity. Do we include 4/3? There's two reasons why we don't. Okay? One reason is the one that Meerkat told us a few minutes ago. You get 0 on bottom. There's an even simpler reason. You know why you don't include it? What's not there? The equal sign. There's no equal sign there. Okay? What I want you to understand is this. Be careful. I'm going to say this very slowly, okay? If you don't see an equal sign, you never include the endpoint. If you do see an equal sign, sometimes you include it, sometimes you don't. Okay? And we'll talk about that more as we get into further problems, okay? But again, what you have to ask yourself is, if it's not there, you don't include it. If it is there, you might. And you get to include it as long as it doesn't make 0 on the bottom. Okay? Because having 0 on bottom, that's not a number.
How
Okay.
are you never going to get 0 on bottom?
Say it again?
How are you never going to get 0 on bottom?
You'll see. We'll get there. Okay? Well, tell you what. I'm trying to think where we got one. We'll get there eventually. Well, okay, I'll tell you what. I thought I saw it. No, you'll see eventually. I can't do these in my head. All right, number 15. This will be the last one for the day. Okay, so we have 2 over 1 minus x squared. Okay, 0 on one side, that's great. We like 0 on one side. Okay. Okay, critical value, there's only one of them. What is it and why?
1.
Why? How come? What's so special about 1?
1 minus 1 equals 0.
You gotta be more specific. 0 where? On the bottom. It makes 0 on bottom. Okay, it makes 0 on bottom. Okay. Let's do this. So let's draw our number line. We plug in 1. Okay. Or we put 1 on the number line. Pick a number to the right of 1. I'm going to plug in 100,000. Okay. 1 minus 100,000 is a negative. Squared. What's a negative squared?
Positive.
Positive. What's 1 over a positive number? Okay, let's pick a number to the left of 1. I'm going to plug in negative 100 trillion. Okay? If I plug in, be careful on this, 1 minus negative 100 trillion. What's 1 minus minus 100 trillion? Positive squared. Okay, what's a positive over, 2 over a positive number? Did they flip-flop? No, they didn't. They went plus plus. What do we care about? Where it's positive or it's negative?
Positive.
Bigger than 0. Positive, okay? Gotta be careful on this one. So, it's positive here, it's positive here, so is it positive everywhere? Almost. It's almost positive everywhere. Where isn't it positive?
1.
At 1. What happens when you plug in 1? You get 0 on bottom, you don't get to plug in 1. So, it's positive for every single number you could ever think of except for one case. Can't plug in 1. You can't plug in 1.
So all except 1?
It's all real numbers except 1. So here's how I want you to write it, okay? It's everything to the left of 1 as well as to the right of 1, but we don't include 1. So how do I say to the left of 1? What's the farthest thing to the left? Negative what? Infinity, comma, positive 1. Do I include negative infinity?
No.
No. Do I include 1?
No.
Or, what's this area? What's the smallest? 1, comma what?
Positive.
Do I include? That looks terrible.
No,
You
you
get the
don't
gist.
include either.
That's your answer. It's basically, that's a way of saying every number, everything works except for 1. Because think about it. When you square a number, forget about 0. Forget about 0. True or false? Any real number squared is a positive. When you square a real number.
Yeah.
Because what's a positive number squared? Positive. What's a negative number squared? Positive. Now 0 doesn't count. Okay, don't forget 0. And what's a positive over a positive? It's a positive. But is 1 minus x squared always positive? Almost. It is, except for when you plug in 1. Then you get 0. All right, we're done for today. Okay, these will get a little tougher.